All right, a car accelerates uniformly for 8.70 seconds. That's our time then, right? 8.70 seconds with a final velocity of 31, but that's our final velocity. Okay, let's see. Over a distance of 216 meters, what was its initial velocity? I think that's our displacement, right? 216 meters. What was the initial velocity? So I guess we use no A, right? And that's going to be what? X equals 1/2 VI plus VF times T. So let's plug that in. X is 216, is 1/2. And then VI is what we're trying to solve for. VF is 31.5 times 8.7. Okay. Now let me just say that we're not very good at solving this. So let's not cause our math teachers any random, unexplainable abdominal pain by abrogating the laws of mathematics. Okay. Notice that there's a 1/2 here. Okay. So the first thing I'm going to do is I'm going to multiply both sides by 2 to get rid of that. Okay. Everybody forgets to do this, right? So twice 216 is 432. Is VI plus 31.5, right? Times 8.7, right? Now notice that you can't ignore these parentheses. They're still there, right? And so the next thing I'm going to do is I'm going to divide both sides by 8.7, right? So divide by 8.7. Now we're getting somewhere, right? And I get that this side is 40, so then this side's divided by 8.7. That gets rid of the 8.7, right? And I get 49.655 is the initial velocity plus 31.5. Now I can get rid of the parentheses. There's nothing multiplied by it or divided or anything. So now I can ignore the parentheses, and then to solve for VI, I'm just going to subtract 31.5 from both sides, right? And I get 18.155. So my VI is 18.155 meters per second. It would be reasonable, to round this to 18.2, right? So the initial velocity is 18.2 meters per second. So again, your steps for solving this for one of these guys, get rid of the 1/2 first. Get rid of the T that's outside. Now you can ignore the parentheses, okay? You got to do all that first, though. Do those first. It's like order of operations. Okay.